In this video, we'll be looking into the important concepts of fifth module, that is artificial neural networks and clustering algorithms. So if you have not watched my previous video, I've explained all the important questions module-wise. So as an extension to that, I'll be discussing the answers or the important topics in this video. So let's start from artificial neural networks topic. So firstly, understanding the definition of ANN. So basically, ANN imitates the human brain behavior and the way in which learning happens in humans. So ANN can be classified as the computational models inspired by human brain. Okay, so they consist of interconnected nodes or neurons that process the info, similarly how biological neurons does. So ANN can learn from data, making them valuable for solving complex problems in various fields like computer science, medicine, and so on. So in ANN, nodes receive the input, process the calculation, and pass the output to the other nodes, allowing the network to learn and solve complex problems. So this was about ANN. If they ask the definition, we can write these 3-4 points there. Then we have the biological neurons. So biological neurons are this. You need to draw this diagram. So here we have the cell body. These are the dendrites, and this is the axon part. And here is the output, and the connection between the other output to this neuron, that particular point is called synapse. So there are 4 parts majorly. One is body of neuron called soma. So dendrites accept input info, process in cell body called soma. Single neuron connected by axons to around 10,000 neurons make through it. So neurons get fired if info crosses a threshold value and transmits the signal to the other neuron. So once the neuron gets fired, only then the information is transferred to the other neuron through synapse. So synapse gets fired with electric signal impulse called spike, which are transmitted to another neuron. So this was about biological neurons. We'll look into the artificial neurons now. So artificial neurons comprise of a cell body, axon, and then outputs. Here are the weights linked to the corresponding inputs. So we have neurons, those are considered as nodes here, connectivity, links, and each connection link associated with synaptic weight. So these are the weights. So looking into the model of AN, so this was the first mathematical model designed by McLaw and Pitts in 1943. So this includes 2 steps. First one is to receive the weighted input from the other neurons and then operate a threshold function or activation function. So received weights W are computed as weighted sum. So this gives the activation function. So if sum exceeds the threshold, neurons get fired and then the info is transferred. So neuron receives set of inputs x1, x2, xn and weights w1, w2, wn, and then summation of those are done. That's called as net sum, xi into wi. So activation function is here it is binary step function. So if the output would be 1 if net sum is greater than the threshold value theta. If the net sum is less than the theta, then we get output as 0. So the function here is activation function of net sum. Output of neuron y is dependent on this. So if it is 1, output of neuron is y if f of x is greater than theta, greater than or equal to theta. 0 if f of x is less than theta. The same thing we have written it here. Then we have the diagram here. So the model can represent only few Boolean functions. There are a set of Boolean functions: NAND gate, AND gate, XOR gate, and XOR gate can't be performed by this. Okay, this simple model. So weight and threshold values are fixed in this model. Even the weight and threshold values are fixed in this model. So this is the diagram representation. Here we have different inputs along with the weights, and then here we have the sum, net sum function being happening here, and then here is the activation function. Here we have the threshold. Depending on the threshold, the output would be decided. So this was about simple model of artificial neuron. Next we'll look into the structure of ANN. So as we have discussed earlier, it mimics the human behavior structure and the function also. So ANN is represented as directed graph with neurons as nodes and connections as links. We have seen this in the previous topic. Nodes arranged in different layers for obtaining the parallel processing. Each neuron uses the activation function to map the input to non-linear output. So here we have the 3 layers. So first one is the input layer, which receives the info, passes it to the hidden layer through edges with connected weights. Then we have the hidden layer here in the middle. So it computes based on the input and fire if sum of weighted input exceeds threshold. We have discussed this earlier. Then we have the output layer. So the final output is given here, and then only a single value would be generated as output. Now we'll look into the activation function topic. So this could be asked for 5 marks or even for 8 marks or 9 marks also, because there are nearly 8 there are nearly 9 activation functions, so they can ask us to write all of them. So understanding the definition first, mathematical function associated with neuron to map the input signal to the output signal. So it decides whether to fire a neuron or keep it or not based on the input signal. So normalize output value of each neuron either between 0 and 1 or -1 to 1, because the output here should be 1, right? So that's why it can either range from 0 to 1 or -1 to 1. We'll discuss this in the further part. So we have two types of activation functions, linear and non-linear. So linear one is input is 2 or more, they take one input and generate 2 or more groups. Binary perceptrons are example of this. Non-linear ones are the continuous functions. So here input is in the range of 0 and 1 or -1 to 1. So first we have the linear function. Linear function, if the value of x increases, the f of x value also increases. Useful when we don't want to apply any threshold. So here threshold is not required. Output is only weighted sum of input. So the output value ranges between -infinity to infinity. Then we have the binary step here. So binary step function generates the binary output. Either it could be 1 or 0. 1 when f of x is greater than the threshold value or equal to threshold value. 0 if it is less than threshold value. Then we have the bipolar step function. Bipolar step function is, it can have either -1 or 1. Okay. So if it is 1, the same condition, threshold should be greater than or equal to theta. If it is -1, it is less than theta, threshold function. Then we have the sigmoidal or logical function. So sigma of x is equal to 1 by 1 plus e power minus x. So this is a non-linear function. S-shaped curve would be obtained by this, and then output should be between 0 and 1, and it has vanishing gradient problem. That is, when we take large chunk of values, the output may not be accurate in this condition, sigmoidal function. Okay. Then we have the bipolar sigmoid function. So here it is extension to this. Sigma x is here 1 plus e to the power minus x, as it is above you write 1 minus e to the power minus x. So the output is between -1 to +1, and most of the things are same here. Vanishing gradient problem is seen here also. Then we have the ramp function. So here the value ranges between 1 to 0. And the limit is set between 1 to 0, and if the value is between 0 and 1, we get whatever the input is given, x would be the value. So it is a linear function. Upper and lower limits are being set, value is fixed. So this was about ramp function. Then we have the tanh function. So tanh or hyperbolic or the hyperbolic tangent function. So here we write tan h of x is equal to 2 times 1 plus e power minus x into -1. So this is non-linear scaled version of sigmoid function, and the output is between -1 to +1. Then we have the rectified linear function. So in this, this is used in deep learning neural networks. It avoids vanishing gradient, the problem which we faced in sigmoidal, bipolar sigmoidal, and even in tanh also this problem is seen. So avoids the vanishing gradient. If the input is positive, then it will take r of x is equal to maximum of 0, x. So x, we would get x if x value is greater than or equal to 0. If it is less than 0, then we get 0. So if the input is negative, then we get 0, 0 itself. Then we have the softmax function. This is the 9th function. S of x is equal to e power x by summation j is equal to 0 to k e power x j, where I is equal to 0 to k is the limiting, the final setback. Here this is a non-linear function, output between 0 and 1. It can handle many classes. That is, by making use of softmax function, we are exponentially dividing one particular input. So in order to remember this activation functions, you can remember it as LBB, LBR, TRS. Okay, 9 activation functions: linear, and then binary, bipolar, sigmoidal or logic, bipolar, sigmoid, and then ramp, tanh, rectified, and softmax. You can remember it this way. Next topic we have is types of ANN. So there are majorly 4 types of ANN. So the ANN types differ based on the network structure, the activation function, and the learning rules. So firstly we have feed forward neural network. So in this, by the definition we can understand the inputs are fed in the input layer, and then they are sent forward, only forward direction, input to output unidirection, no feedback loops. It is simple, not for sequential data. Regression, pattern recognition are done in this. This neural networks are being used in those places. Then we have the fully connected neural network. In this, each neuron is connected to every other neuron. Okay, it is flexible, expressiveness, and then it is used in general purpose tasks. Then we have the multi-layer perceptron. So in this, there could be many hidden layers. So it is a type of feed forward in which there are many hidden layers. So this is used to solve complex problems. It is prone to overfitting. It is used in time series forecasting. Then we have the last one, that is the feedback neural network. So you give an input, and based on the hidden layer, the outputs are generated, and from the outputs, the feedback is given back to the hidden layer. So cycles in their connection are being established here. So it maintains the memory. So loops or feedback into the network. So handling sequential data, it can suffer vanishing gradient problem. It is used in natural language processing and speech recognition. So this was about types of ANN. So if they ask, I hope you can write this very easily. Then we have the applications of ANN. There are n number of applications. You can, depending on the marks, you can write. First one is face recognition, emotion detection, and self-driving cars. Then in business, we have stock trading, sales forecasting. In banking, we have currency price prediction and many others. In education, we have adaptive learning software, and then students' performance monitoring. And then in healthcare, we have image interpretation, drug discovery. We use it in robotics, aerospace, electronics. So you need to expand this and write. Okay. Then we have the advantages. So it can solve complex problems involving nonlinear processes, the first one. Then it can learn and recognize patterns. It is used in parallel processing. It can handle incomplete and noisy data. It could scale well to larger data set also. Then the limitations are it requires processors with parallel processing capacity. And then it works like a black box. So in the hidden layer, you won't understand working of inner layer is difficult here. So that's what limitations are. Next, we'll look into the perceptron model. So perceptron is a unit used to build ANN system. So there are 4 steps in this. Firstly, input from other neurons are taken, and then weights, depending on the weights and bias, net sum is calculated. Then it goes to the activation function, and accordingly, depending on the threshold value, the output is decided. So here we have a set of input x1, x2, xn. Then we have the weights w1, w2, w3, wn. Then we have the net sum, that is these two, product of these two added. Then we have the activation function, which is equal to net sum plus bias. So activation function is a binary step function. Binary step function, if it is output would be 1 if the activation function is greater than or equal to threshold. It would be 0 if it is less than threshold. Now we'll look into the perceptron algorithm. So this is important, so they can ask the algorithm along with the problem. So in the algorithm, initial weights set as w1, w2, wn, bias theta to the value in range. The bias value could be in the range minus 0.5 to plus 0.5. For each epoch, find the weighted sum. First step is to find the weighted sum, and then apply the activation function, that is x1 plus w1, x2 plus w2 minus theta. Then if the sum is greater than theta, then output is positive, else it is negative. Error calculation by subtracting the output estimated from the desired output. So by subtracting these two, you can get the error. So if the error is positive, then increase the output y, value of output y. If not, decrease the output value. Then after finding this, we'll look into updating the weights after error. So delta wi is equal to lambda e to the power e of t into wi, where x is the input value, e of t is error at step t, alpha is the learning state, and delta of wi is the difference in the weight. So this was about perceptron algorithm. So here we have the multi-layer perceptron algorithm. I would suggest that if you get perceptron and multi-perceptron, there's a choice between these two, then go with the normal perceptron, because multi-layer perceptron is pretty difficult. Here you need to perform 2 steps, forward propagation and backward propagation. It is very time consuming also. So it will be available in the notes. I'll upload it. Do have a look. Now we'll look into the radial basis function. So radial basis function neural network. So here we have an input, that is the input vector x1, x2, xn, and output we need is y of n. So assign random weights. It has to be between -1 to 1, and then calculate the input and output info. So firstly, the input would be same as whatever the input they have given, and output would also be the same specified in the input vector. Then we have the hidden layer. So in hidden layer, perform Gaussian radial basis function, that is hj of x is equal to e power minus x minus cj square by r square. We'll understand this while solving the problem. Then we have the weighted sum. So w of x into hj of x multiplied, and then compare the weighted sum. If it is greater than 0, then put 1. If it is less than 0, then put 0. Now compare the output which was given in the input vector to the output which you have obtained. So if they are same, you are good to go. If else, if not, then backward propagation needs to be done. Now we'll look into a problem here. So they have given the values here, XOR values are given here, and we need to perform the radial basis function on neural network. Okay, so under this topic, the question is given. So we need to perform this operation. So my first step would be to calculate, to consider the inputs. That is, I'll take the inputs as 0, 0, 0, 1, 1, 0 and 1, 1. I'll name it as case 1, case 2, case 3 and case 4. So the outputs for this are 0, 1, 1, 0. So similarly, the output also would be 0, 1, 1, 0, because there's no operation being specified here, right? So I have taken my input and output for the input layer. First step is done. My second step is, for the hidden layer, I need to calculate the Gaussian radial basic function. So I'll start from h1 of x. There are 4 functions here, right? h1, h2, h3, h4. For h1 of x, I can write e to the power minus x minus c1 whole square by r square by r square. Again, for h2x, it would be e power minus x minus c2 whole square by r square. For h3, it would be e power minus x minus c3 whole square by r square. And for h4 also it will be the same. Here c4 whole square. Now we'll see how to calculate this. So firstly, I'll consider the first point they have given, that is c1 value, that is 0, 0. Now I need to calculate the distance square of x from c1, c2, c3 and c4. In order to calculate h1 of x, that is with c1, I wrote c1 first here. Next I'll write other conditions, that is 0, 0, and then c2 is 0, 1, and c3 is 1, 0, and c4 is 1, 1. Now that I have written this, here my equation says e to the power minus x minus c1 by r square, this whole square. Right, my equation says that I need to find this particular value in order to get h1 of x. But then I don't know what is this x here. So in order to calculate this x, we'll take first instance as 0, 0 in this place of x, then 0, 1, then 1, 0, and then 1, 1, and subtract it with this. Find the distance. We are basically finding the distance here of the form d square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. So I'll calculate the distance here. I can write 0 here, this 0 minus 0 whole square plus 0 minus 0 whole square, I would get 0 here. Now I'll calculate the e power, this formula. Now here r value is taken as 2. So here r square value we need to calculate, right? So r square value is taken as 2 here. So that will be given in the question itself. So if I put the equation in Cal C, I can write e power minus, I'll put x here, minus x divided by 2, right, and I'll solve it. So here this value is, x value here I have obtained is 0. So if I put 0 here, I would get 1 as the result. So the value is 1 here, the entire thing is 1. Next I'll take 0 minus 0 whole square plus 0 minus 1 whole square. The result would be 1 here. Next again here 1 minus 0 is 1 square plus 0 minus 0 is 0 square, I would get 1. Next I have 1, 1. So 1 minus 0 is 1 square and 1 minus 0 is 1, so 1 square. So I'll get 2 here. So substituting the values now. Next input I'll give 1. So I got 0.60. Next again I have 1, so again I'll write 0.60. Next I have 2 here as the input. So if I put 2, I get 0.3679. Okay. So now that I have obtained the E values, my next step would be to calculate the weighted sum. Next step would be to calculate the weighted sum. So I would get it as, so firstly this 1, multiply it with x1 weight. So x1 weight is minus 0.8. So 1 into minus 0.8 plus x2, this 0.6 into this 0.9. Next I have 0.9 here and here 0.6. And then here I have 0.36. I'll round it off to 0.4 because it was given 0.4 in the textbook. And here I'll take minus 0.8. So if I solve this, I would get minus 0.04. So I am done with C1.C1. Next for C2 I'll write, C2 I'll consider 0 and 1. Right. And here I'll write C1 as 0, 0, C2 as 0, 1, C3 as 1, 0, and C4 as 1, 1. So I'll quickly write value for this. So writing the distance here, so it would be 0 minus 0 is 0, 0 minus 1, so 1 square is, I got the value as 1 here. Again the value is 0 minus 0, 1 minus 0 is 1 minus 1 is 0. Here 1 minus 0 is 1 and 0 minus 1 is 1, so I get 2 here, and here I have 1 minus 0 is 1 and 1 minus 1 is 0, so 1 here. So depending on this, I'll calculate the e power values. So here I had got 1, so 0.6. So for 0 it is 1, for 2 it is 0.4, we have taken 0.4, and for 1 it is 0.6. Now my next step would be to multiply this with minus 0.8, 1 with 0.9 and 1 with 0.9 and 0.64 with 0.9 and 0.6 with minus 0.8, and then add these, I would get 0.3. So one thing, this value, is it greater than 0 or lesser than 0? It is lesser than 0, right? So I'll take C1 as 0. Okay. Now for C2, this is greater than 0 or lesser than 0? This is positive, right? So I can write it is greater than 0. So I'll write 1 here. So for this, for C1 I've got 0, for C1 I've got 0, for C2 I got 1. Similarly for C3 I'll quickly write. So 0, 0, 0, 1, 1, 0 and 1, 1. Calculating the distances, 0 minus 1, 0, 0, so I get 1 here. Here I get 2, here I get 0, here I get 1. Writing the e power value here, I would get 0.6, 0.4, 1 and 0.6. Now again multiply this 0.6 into minus 0.8, 0.4 into 0.9, 1 into 0.9 and 0.6 into minus 0.8. I would get 0.3. This is again greater than 0, 1 for C3. Now for C4 I write 1, 1. So again calculating the values 0, 0, 0, 1, 1, 0, 1, 1. I'll calculate the distance, so I get 2 here, 1 here, 1 here and 0 here. Now I write the e power value, so that is 0.4, 0.6, 0.6 and 1 here. Next, if I multiply these with this with 0.8, this with minus 0.8, this with 0.9, this with 0.9 and this with minus 0.8, and add these, I would get minus 0.04, which is less than 0, right? So I can put 0 for C4. So for C1, after calculating output, I got 0, right? And checking here, for C1 I had got 0. So first condition done. For C2 I got 1. Here for C2 I had to get 1, done. For C3 I got 1. Here C3 I had to get 1, done. And for C4 I got 0. Here for C4 I had to get 0. So this was the only question given in the textbook. So if this topic is included in the paper on Monday, then this question would be there, and I would suggest you to go through this once. And this is pretty easy to solve compared to the multiple layer perceptron algorithm, so you can easily score marks in this. Next we'll be looking into the perceptron question, so AND gate question. So they have given AND gate, they have said that we need to construct a perceptron model for AND gate. So the inputs we know, so there would be 4 inputs, 0, 0, 0, 1, 1, 0, 1, 1, and accordingly the outputs would be, for AND gate, everything we get 0, only for 1 we get high. So activate this constant value also, they have given lambda is equal to 0.2. This lambda is the learning rate, they have specified it here. And then W1 value is given, W2 value is given. We need to start solving this. So firstly, we know, let me consider the first iteration or the first epoch. I'll start solving it. So firstly I write the values as it is 0, 0, 0, 1, 1, 0, 1, 1, and estimate y expected. So I want 0, 0, 0 and 1. Then on this side I'll write y obtained. Okay, y whichever I obtained by solving, I'll write it here, and then here I'll write the error, and then here I'll write the W1 value, and here I'll write the W2 value, and the status, if there's any change required happening here or not, that would be mentioned here. So firstly I need to calculate the y obtained value. So in order to calculate the y obtained value, the formula is W1 x1 plus W2 x2 product of summation of this minus the theta value. Theta value here is 0.4. So W1 value I know it is 0.3 and 0.4. So sorry, minus 0.2. Okay, here it is 0.4. This is minus 0.2. Okay, so I'll start solving this. 0.3 minus 0.2. I'll start solving this. So for the first question, if I substitute W1, this is x1, this is x2. So 0 into 0.3 and 0 into minus 0.2, I'll get 0 itself. Between these two errors, if you subtract, you get the error. Y decided minus Y obtained would be the error. Okay, so if Y obtained value is greater than or equal to theta, then put 1. If Y obtained is less than theta, then put 0. Okay, so first step, error is 0, so it would be the same weights, so no change here. Next, I'll consider 0 and 1 is here, so 0 into 0.3 is 0, 1 into minus 0.2 is minus 0.2 minus 0.2 minus theta value is 0.4, minus 0.2 minus 0.4 is minus 0.6, it is less than 0, so I'll put 0 here. Expected, or what we had decided was 0, obtained was 0, so there is no error, so here also no change. Now I'll write 0.3 here, minus 0.2 here. Now I'll check. 1 into 0.3 is 0.3. So for first one I get 1 into 0.3 is 0.3 minus 0 into 0.2 is 0, right? So minus 0 here, minus I would have 0.4 at the outside. 3 minus 0.4, we get minus 0.1. So this is not greater than 0. So I should write 0 here. Decided was 0, obtained was 0, so there is no error. So this weights would be the same, no change. Now coming to this, I have 1 into 0.3 minus 1 into minus 0.2. I would get 0.3 plus 0.2 as 0.5. 0.5 minus 0.4 is 0.1. 0.1 is greater here, so here I would get minus. But then I had to obtain 1, but then I got 0. So there's a variation here, right? So 1 minus 0 is 1. Error would be 1 here. So W3 value needs to be changed, W2 value needs to be changed. So for the change of value, I can write for 1, 1, I can write delta W1 is equal to learning rate e to the power t x1. So learning rate is 0.2, they have given in the question. E to the power t value, E value is 1, and x1 value is also 1. So I would get 0.2 here. And now I'll update the W1 value, that is W1 plus delta of W1. Previous W1 was 0.3, now new W1 I've got it, delta W1 I've got it as 0.2, so it will be 0.5. So here I'll write 0.5, and for W2, same, delta 2 is equal to alpha E2 ET x2 0.2. Here it will be 0, so here it will be 1, and here it will be 1, so 0.2. Now W2 is equal to W2 plus delta W2. W2 value is 0.2, they have taken, minus 0.2, and here I have plus 0.2, so this would be 0. So here change is happening. So I am done with the first epoch. Now I'll move on to the second epoch. I'll write the values first. 0, 0, 1, 1, 0, 1, 0, 1. Then I have 0, 0, 0, 1. And on this side I have 0, 0. This I need to calculate it. So first two would be, there won't be any change. Next two only there will be change. So this is Y decided, and this is Y obtained. This is x1, x2. And here I'll write the error. Here I'll write the W1 value. Here I'll write the W2 value. And here I'll write if there is any change happening or not. So previously the new W1 values and W2 values we had obtained was 0.5 and 2. 0.5 and 0. Sorry. So, okay, so 0 error, 0.5 and 0.0 here. So no change. Here also 0 error, 0.5, 0 and no change. Now moving on to this, I need to subtract. So 1 minus 0.5 into 1 is 0.5 minus 0 minus 0.4. So it is 1. So it is 0.1, right? But then I had to get 0 here. So when I subtract these two, I would get error as minus 1. So when error is minus 1, I need to calculate the new weights. For 1, 0, I write delta W1 as alpha e power t x1, which is equal to 0.2, 1 and minus 1, that is minus 0.2. Now writing the W1 value, that is 0.5 plus minus 0.2, I would get 0.3. So here I would get 0.3, and for delta 2, I would get 0 after solving. So here change is happening. Now considering these, I would check for this. 1 into 0.3 is 0.3, and here 0 into 1 is 0. So 0.3 minus I need to subtract 0.4. So 0.3 minus 0.4 is minus 0.1. But then if I get minus, I'll put 0 here, right? So I had to get 1, but then I got 0 here. So I'll put 1 here and then calculate the new W values here. So calculating the new W values, for W1 I would get 0.5, and for W2 I would get 0.2. I'll write 0.5 and 0.2 here. Change is happening. I've directly written these values, so you need to perform the same operation. Next, for the third epoch, I'll write the values 0, 0, 0, 1, 1, 0, 1, 1. The x1 and x2 values. Next I have Y decided and then y obtained, and then if there is any error, to depict the error, and then the weights followed by the status. So 0 0, I need to get this. So here weights, I had recently got 0.5 and 0.2, right? So I'll assume that these are the weights. So I'll move on, I'll keep on checking. Okay, so firstly 0.5 into 0, this will be 0 itself. Here also it would be 0, error is 0 0, no change, no change. Next here I'll check 0.5 into 1 is 0.5, 0.2 into 0 is 0. So 0.5 minus 0.4, I got 0.1. 0.1 is greater than 0, I need to put 1 here. But then I had to get 0 here, so the difference would be minus 1. And if I calculate the W1 value, delta W1 value would be W1 value would be 0.3 and W2 value would be 0.2. So I'm directly writing the values here. So change has happened here. Now considering these two, I'll calculate for these. So if I calculate 0.3 into 1 is 0.3 plus 0.2 into 1 is 0.2. So 0.3 plus 0.2 is 0.5 minus 0.4. I would get 0.1, which is greater than 1, which is greater than 0. So I'll put 1 here. The error is 0. So it would remain the same, no change. So next step, I'll write the same values again, 0 0 0 1 1 0 1 1, x1 x2. Then I have the y decided, y obtained, and then any error, w1 w2, and then the status. So writing the values here, first two it would be the same. So here 0.3 was there, right? 0.3 0.3 0.2 0.2, here no change. Now I'll check for this 0.3 into 1 0.3, this is 0. 0.3 minus 0.4 is minus, so I'll get 0 here. Okay, here also 0, here also 0, here 0.3, here 0.2, no change. Next, coming to this 0.3 plus 0.2 is 0.5, 0.5 minus 0.4 is 1, 0.1, so here I would get 1. So here I had to get 1, here also I got 1, error is 0. I can retain this as same, so here also no change. When I get no change status in all the given values, that means that our perceptron for that particular gate is ready. We are able to solve it. So depending on these inputs and these weights, we can get the output accordingly. So that's what this question says. Next, moving on now. So clustering analysis is technique of partitioning of collection of unlabeled data or objects that has many attributes into meaningful or disjoint groups or clusters. So there are no supervisors available here. That is, when no supervisors are available, we need to perform trial and error. So by performing trial and error, we would get the output, or we would be able to construct the clusters. This is unsupervised learning. That's what I said. So clusters are represented by centroids. So if I have these 3 points, I need to calculate its centroid. So 3 plus 2 plus 7 by 3, 3 plus 6 plus 9 by 3. I would get 4 by 6. So this is the centroid for these clusters. Okay. Okay, or we can say that these points fall under this cluster. So clusters should not overlap and each cluster should represent one class. So again, yeah. Then we have the difference between clustering and classification. So classification is supervised, whereas clustering is unsupervised. In clustering, we make use of unlabeled data. Here we make use of labeled data. Here no prior knowledge is required. Here prior knowledge or the knowledge of domain should be present. Here it results are dynamic. So depending on our wish, if we wish to do another iteration, then the values could change there. But then here, once labeled, it can't be changed. So this was about the difference. Elaborate it and write. So then we'll look into the applications. So grouping based on the customer's buying patterns. So that could be done in clustering. So information retrieval, identification of genes that cause influence of disease, data compression, document indexing, and many other applications are there. Now we'll look into the advantages and disadvantages. Advantages are that clustering can handle missing data and outliners. So it can help classify and labeling unlabeled data. Semi-supervised algorithm use clustering analysis. So it is easy to explain and obtain and implement. So it is oldest technique in the statistics clustering. Now we'll look into the disadvantages. It is sensitive to initialization and order of input data. So often the number of clusters present in data have to be specified by the user. Then scaling is a problem here, and designing a proximity measure is again an issue here. We'll look into the challenges. So collection of data with high dimensions could lead to the issues or challenges. Then we have designing proximity measure. Then we have curse of dimensionality. So these are the challenges. We'll look into the proximity measures. So clustering algorithms, clustering analysis needs a measure to find similarity among the objects for grouping. So this similarity or dissimilarity are collectively called as proximity measures. So here we have the distance measures. So it speaks of dissimilarity, that is from the given object, how different is the object taken. So how object is different from the other, that's what dissimilarity speaks. And cosine similarity tells about the similarity among objects. Distance between two objects, let's say they are I and j, denoted by distance I comma j. So the properties of distance measures are always the distance has to be positive and or it could be 0. Distance between the object and itself would be 0. And then if distance ij is equal to distance ji, symmetricity, and then distance ij should be less than or equal to ik plus kj, that is triangular inequality. If all above conditions are satisfied, then it is called as metric. We'll look into the quantitative variables. So firstly, we have the Euclidean distance x2 minus x1 whole square plus y2 minus y1 whole square and so on. And then we have the city block or Manhattan distance. Here we are doing square, right? So here don't do the square, just write the values x2 minus x1 plus y2 minus y1 plus z2 minus z1, that's it. And this distance, so that is taking the maximum among the values which we have found. And then we have a Minkowski distance, which is the sigma of x minus x1 minus x2 minus x1 to the power 1 by r. This won't be asked usually. I've not seen this question in the textbook or in the exercises. So here the Hamming distance, number of position at which the characters are different. I have 110 and 100. So in this position, in the middle position, the values are changing. So at one character, the values are being changed. So I can write 1. Then we have the categorical variables. So distance x comma y is equal to 1 if x is not equal to 1, y, 0 if x is equal to y. Then we have the ordinal values. So x comma y, position of x minus position of y by n minus 1. We'll look into the problems here. So here 0.3055 comma 8, the values are given, 2 points are given. We need to calculate Euclidean, Manhattan and this distance. So firstly, calculating the Euclidean distance, x2 minus x1 whole square, y2 minus y1 whole square under root. So we would get the value easily. Then Manhattan distance, 0 minus 5 and 3 minus 8 under mod. So I would get 10. Then for this, I need to select the maximum. 0 minus 5 is 5 and here 8 minus 3 is 5. So out of these two, select the maximum one. I selected 5. Then the next question we have is the vectors are given, the values are given 1 0 0 1 1 1. I need to calculate the simple matching coefficient, Jaccard coefficient and Hamming distance. So for simple matching coefficient, I would take a as 0, b as 2, c as 0, d as 1. So I would get a plus d, so 0 plus 1, and this entire thing is 3. So I would get 0.33. Then for Jaccard distance, Jaccard coefficient, I would get d by b plus c plus d. So 1 by 3, 0.33. And for Hamming, I would get 1 0 0 1 1. If I have 1 0 0 and 1 1 1. Here two positions, the values are changing, right? So I can write 2 here. Then we have the cosine similarity. So the formula is sine of x comma y is equal to x dot y by mod of x into mod of y. So here we perform the dot product, 1 into 0 plus 1 into 1 plus 0 into 1. I would get 1. So the normal of vector a and b is under root 2. So cosine similarity is 1 by under root 2 into under root 2. I would get 1 by 2, 0.5. Next we have, they have said distance between yellow, red, green and red, green, yellow. So for this we'll be making use of this ordinal values. So we'll consider yellow as 1, red as 2, green as 3. So finding yellow and red distance. So 1 minus 2 by 2, that is 0.5. Then for red and green, I'll write 2 minus 3 by 2, 0.5. Then for green and yellow, I would get 3 minus 1 by 2, that is 1. That is 1. Now we'll look into the k-means algorithm. So k-means algorithm determines, the algorithm says to determine number of clusters before algorithm is started, k. Then choose k randomly, initial cluster centers, find mean, assign the remaining sample closest cluster using Euclidean distance. Then compute new centroid taking the new samples. Perform 3 and 4 until the clusters are in same, the values are in same clusters. So here they have provided the values, here x and y values are given. And they have said that initial value of objects are 2 and 5. So we need to take initial cluster values as 2 and 5. So 2 would be one cluster and 5 would be one cluster. So I'll draw a table for this. 1, 2, 3, 4 and 5. And on this side I have x and y here. Here it would be 2, 4, 4, 6, 6, 8, 10, 4 and 12, 4. Now they have said, they have already assigned two clusters of object 2 and object 5. So object 2 is 4, 6. So I'll write 4, 6 as the first cluster. And then I would write for the second cluster, I would write 12, 4. That is fifth object. Now I'll write here which cluster it would be under. So finding the Euclidean distance, 2 minus 4 whole square plus 4 minus 6 whole square under root. So we would get under root 8. Value is 2.82, and on this side we would get 10, and here it is 4,6. Cluster is 4,6. So we can directly write that 2 falls under cluster 1 and 5 falls under cluster 2. Because it is 12,4. Same cluster is being considered, right? So we can directly write the value. Then for third one, we have 4,8 is there. Third one is 6,8. So for this, if I calculate, I would get 2.82, and on this side I would get 7.211. So out of these two, this is smaller, right? So this would come in this cluster. Here also this is smaller, so it will come in this cluster. 10,4. For 10,4 here I would get 6.324, and here I would get 2. So this is smaller. So this would fall under cluster 2. So now that I have obtained cluster for all the objects, let me write it here. So for cluster 1 I have 2,4, and then 4,6, and then 6,8. Right. And then for cluster 2 I have 10,4 and 12,4. Now I'll write the new cluster here and the new cluster here. So it would be 4 plus 6, 10, 10 plus 2, 12, 12 by 3 is 4. And similarly here I would get 6. And on this side if I add, I would get 11,4. So I've obtained the new clusters. My next step would be to repeat this again. So here objects 1, 2, 3, 4 and 5. And I have x, y here. And then C1 cluster would be 4,6 and C2 cluster would be 12,4. And then here I'll write cluster table. So here I have 2, 4, 4, 6, 6, 8, 10, 4, 12 and 4. So filling the values here, I would get 2.82 and 4. So this will be C1. And for 2 it is C1. And for 5 it is C2. And for 3, if I calculate, I would get 2.82 here and 6.4 here. So C1 only. And for 4, if I calculate, I'll get 6.3 here, the distance, and here 1. So 1 is lesser, right? So C2. So again, I have obtained the new clusters here. So let me write it here. So for C1, I've got 2,4, 4,6 and 6,8. And on this side, I have got 10,4 and 12,4. So if I'll find the new cluster here, so 6 plus 4, 10, 10 plus 2, 12, 12 by 3, 4, and here 6, here also 11 and 4. So I can say that previously obtained clusters and the clusters which I've obtained now are same, right? So that means that this 2,4 is object 1, 4,6 is object 2, this is object 3, this is object 4, and this is object 5. So these two objects belong to the cluster 2, these two objects belong to the cluster 1. So this was about the k-means algorithm. I would suggest you to go through the hierarchical clustering. It has all simple theoretical topics. They can ask the definitions, but majorly problems, if they ask, it would be from k-means only. So I would suggest you to go through the notes. It would be available in the description. And if you have any doubts, do let me know in the comments and subscribe to my channel. Thank you.